Five continents connected by the passion of mathematics. Learn and explore with Anil Kumar.
Hi, Mata Savia. How are you doing?
I'm doing great, sir. Thank you. And how are you?
Very good. Very good. So, Mata Savia, we are going to learn about something about trigonometry today. What do you want to learn? Tell me.
Today I want to learn about double and half angle formula in trigonometric functions.
Compound angle formulas, double angle, and half angle formulas. Sure, we will do that. But before that, I would like you to introduce yourself to all our viewers. Tell me something about yourself, about your country. What do you really like about it? Yes.
My name is Matasavia. I'm from Ethiopia, which is located in Africa, and I'm grade 11 student. And here in our country, Ethiopia, there are a lot of endemic mammals like wally ibex and gelada baboons. There are a lot, and as now there is a lot of tourist sites in our country. I invite our viewers to visit our country, Ethiopia.
I will love to visit your country. But okay, good. That was great. I will love to visit Ethiopia and enjoy. Matasabia is a grade 11 student. He watched some of my videos on YouTube, especially the ones with Emmy. Emmy is my student in UK, and so we have come together. I would like you to join my classes, ignite the spark of learning, and share the passion of learning. Now, let's begin with a lesson on trigonometry. Okay, so read what is written there on the screen. What do you see?
I'm looking about the compound angle formulas.
So we'll talk about trigonometry of compound angles today. So Mata Sabia, you know the compound angle formulas which are mentioned here, which is sine A plus B is sine A cos B plus cos A sine B, right?
Yeah.
But when we have sine A minus B, you get sine A cos B minus cos A sine B. And for cos A plus B and cos A minus B, the formula are cos A cos B minus sine A sine B and cos A cos B plus sine A sine B. Now, from here, how do we derive the double angle formula, which is the formula for sine 2x cos 2x? That is what we will look into in today's video, correct? And from double angle formula, we'll also see how that could relate to half angle formula. Is it okay?
Yeah.
Well, tangent ratio also have these compound angle formulae. Here is the formula for the tangent ratio. Tan A plus B is tan A plus tan B divided by 1 minus tan A tan B. Well, you can derive this formula from the formula we have already learned about sine A plus B and cos A plus B, correct? So tan basically is the ratio of sine and cosine. So if I have tan A plus B, I could write sine A plus B over cosine A plus B. Sine A plus B is sine A plus B cos sine A cos B plus cos A sine B divided by cos A cos B minus sine A sine B. So that is the ratio. Now to get it in tangent form, I'm going to divide both numerator and denominator by the term which is cos A cos B. So if I divide both numerator and denominator by cos A cos B, then the equation can be simplified as shown here. So when I divide by cos A cos B, in that case, the first terms cos B cancels, the second terms cos A cancels. Similarly, in the denominator also, these cosine terms cancel, right?
Yeah.
And therefore, you are left with sine over cosine, which is tangent of the angle. And we do get the tan A plus B, tan A plus tan B in the numerator, 1 minus tan A tan B in the denominator. You get the idea.
Yeah.
Correct? Now, another important thing for us to remember is that what is tan of minus theta? Tan of minus theta is minus tan theta, correct?
Yeah.
So if I replace b by minus b in this particular formula, then the signs will change, and what we get is the formula for tan a minus b. You see that? So the
Yeah.
only difference in these two formulae are that instead of tan A plus tan B, we have tan A minus tan B in the numerator, and in the denominator, we have 1 plus tan A tan B. Correct? So,
Yeah.
knowing these formulas for sine and cosine compound angle, we can always derive the formula for the tangent also. So we have the formula for now. All the trigonometric primary ratios for compound angles, that is sum of two angles. Is this part clear to you, Matasabia?
Yeah. It's correct. Yes.
Now we come to the major question, and that is what you wanted to know. How do we find double angle formulae from the compound angle formulae? So let me now explain to you this particular concept. So double angle formula means 2a, right? So we already know one formula for sine A. Let me rewrite now here. Sine A plus B is basically equal to, can you tell me what? Sine A cos B
Sine A
plus
plus sine B cos
cos
A.
A, yeah, cos A sine B, right?
Yeah.
Okay. Now, let us say if I substitute A equals to B and equals to theta, then what happens? Well, if I say A is equals to B equals to theta, then I get sine of theta plus theta, correct? Equals
Yeah.
to sine theta cos theta plus cos theta sine theta, right?
Yeah.
And on the left hand side, we get sine of 2 theta, right? Theta plus theta. And on the right side, we have sine theta cos theta, which is 2 times sine theta cos theta. Do you see the double angle formula now?
Yes.
So, double angle formula for sine is sine 2 theta equals to 2 sine theta cos theta. Well, you can write x for theta also and get in your standard form, which you see in the book. But anyway, one and the same thing. So, you see, we have derived the double angle formula so easily. You see that?
Yes.
Now, from here, we could actually rewrite many other formulae, but before that, let us go to cosine double angle formula now, right? So can you tell me, how are we going to derive the formula for cos 2 theta? Well, we know that cos A plus B is what? Cos A plus B
A
is
cos A cos B minus sine A sine.
perfect. What should I do next to get double
Then
angle formula?
A is equals to B.
Replace A and B with theta. So we get
Yeah.
cos of theta plus theta.
Theta plus.
Simple strategy, right?
Yeah. Cos of
Very
theta.
simple, very simple. The idea
Yeah.
is to make things so simple that, there's no problem in understanding anything.
Yeah.
Equals to cos square theta minus sine square theta. So we get the formula, double angle formula for cos 2 theta also. Do you see that? So easy.
Yes.
Just replace A and B both with theta. You get 2 theta and you have your double angle formula. Now, cosine double angle formula is very important, and let us see how it could be written in other forms. You remember what is, cos square theta plus sine square theta is 1, right?
Yes.
So we could write cos square theta as equal to 1 minus sine square theta, and we could also write sine square theta equals to 1 minus cos square theta. Now, since we know
Yeah.
this, we could actually replace the terms here. For example, sine square theta with this, correct? And get a new
Yeah.
formula. Similarly, we could also replace cos square theta with 1 minus sine square theta and get a new formula. That is what we are going to do now, correct?
Yeah.
So we know that cos 2 theta is equal to what? cos square theta minus sine square theta, right? Now, if I replace cos square theta by 1 minus sine square theta, what do I get? 1 minus sine square theta, right? I'm replacing cos square theta by 1 minus sine square theta. And then I have sine square theta here. Open the bracket. We get 1 minus 2 sine square theta. You see that? So we get another double angle formula for cos 2 theta. Perfect?
Yeah.
Now, let us do one more variation. This time for cos 2 theta, I'm going to replace sine square theta by 1 minus cos square theta. What will you get? Can you figure it out?
Yeah.
1 minus cos square theta, right? So I'm replacing sine square theta this time by 1 minus cos square theta. So when I open this bracket, I get cos square theta minus 1 plus cos square theta, correct? Which is 2 cos square theta minus 1. So I have another formula, double angle formula for cos 2 theta. And so we can now write three formulae for cos 2 theta. So when we have cos 2 theta formula, once we learned earlier was cos square theta minus sine square theta. And then we also found this could be written as 1 minus 2 sine square theta, and this could be written as 2 cos square theta minus 1. So these are our formula number 1, 2, and 3 for cos 2 theta, correct?
Yeah.
So that is how we get double angle formula from the compound angle formula. Simple strategies. Replace A with B, A and B with theta, you get double angle formula. Once you have the double angle formula, then you could actually refine them. And for example, cos 2 theta, we saw we could write it in three different forms. And we also saw that tan theta, now let's look into the double angle formula for tan theta also, right? Can we extend this here?
Yeah.
Okay. So we'll do for tan theta. We know tan A plus B is what? Tan A plus B is tan A plus
Plus
tan B,
over
1 minus tan A tan B, correct? Our strategy is replace A and B with theta. So we get tan 2 theta, which is theta plus theta. We get tan theta plus tan theta over 1 minus tan theta times tan theta, correct?
Yeah.
So we have the formula, double angle formula for tan also, which is 2 tan theta over 1 minus tan square theta, correct? So now we have double angle formula for sine, cosine, and tangent ratio, correct? Does it make sense to you?
Yes.
Now, we can apply these learnings in many different ways. Now, for example, here, if we have further worked on, so I have shown you how do we derive the formula for tan 2 theta as we have shown here, right? Okay. Now, the question here for you is find the exact value of tan 75. How will you find exact value of tan 75? Tell me.
By adding two special angles.
Correct. So tan
Yeah.
75 can be written as what? Tan 75 degrees can be written as tan
So,
45 degrees plus 30 degrees, correct?
yeah.
And that means you could write this as tan of 45 degrees plus tan of 30 degrees, correct? Divided
Yeah.
by 1 minus tan 45 degrees times tan of 30 degrees, correct?
Yeah.
And you know these angles, they are special triangles. We can always work out their relation using these special triangles, right? So tan 45, let's say this is 45 degrees, which means 1 square root 2. And for tan 30 degrees, we can have 1 2 square root 3, where this is the 30 degrees angle, right? So substituting the values, we get tan 45 is 1 plus tan 30 degrees. 30 degrees will be what? 1 over square root 3, right? And here we get 1 minus 1 times 1 over square root 3, right? So that's what we get. You can actually multiply by square root 3 and then rewrite this. So let me do this. So we have square root 3. Let me push this page forward. Okay. So we have square root 3 plus 1 over square root 3 minus 1 in our answer. Now, it is very important to rationalize. So remember that we normally want to rationalize our answer, correct? So I'll extend this and rationalize this, multiplying by the conjugate of the denominator, which is square root 3 plus 1, correct?
Yeah.
So when you do the numerator, you get a plus b whole square, and this could be written as 3 plus 2 times square root 3 plus 1, and the denominator gives you 3 minus 1, and you can now combine this as 4 plus 2 square root 3 over 2, and that can be written as dividing by 2, you get 2 plus square root 3. Does it make sense to you? So we have used the compound angle formula in this particular case, and we have found a value, exact value of tan 75. Do you see that?
Yes.
Which is equals to 2 plus square root 3. Correct? So that is one of our applications. Now, let us look into the half angle formula derivations. Is that okay? So
Yeah.
now we are going to look into half angle formula. How do we derive half angle formula? Well, we can begin with the double angle formula to derive the half angle formula, right? We could do that, correct?
Yeah.
So now let us see how do we actually derive this particular formula. So we know cos 2 theta is what? One of the formula which we learned was 2 cos square theta minus 1. You remember that when we reduce it, right?
Yes, sir.
Now this particular formula, we can rearrange. And let me do a substitution here. And the substitution is let 2 theta equals to x, right? Then theta will be equals to what? Half of x, correct? So I'm going to write 2 theta as x. So I get cos of x equals to 2 times cos square of x by 2. Do you see how I get half angle there?
Yes.
I can rearrange and I can write this as cos x plus 1 equals to 2 cos square x by 2, right? Now I can divide by 2. So you get cos x plus 1 divided by 2 equals to cos square x by 2. Perfect?
Yes.
Now I can square root it. So if I square root it, what do I get? I get the formula for cos x by 2. And that is square root of, I can write this as 1 plus cos x, correct? Over 2. And whenever you square root, you have to write plus and minus, right? Very important. Plus and minus really helps. You have a choice now. Choice is dependent on in which quadrant you are. So you know the cast rule. So if x by 2 is in the first quadrant, then it is positive. But if it is in second or third, it is negative, and it is positive in quadrant number 4. So depending on where x by 2 is, we can choose the sign plus or minus. You get the idea?
Yeah.
So that is how we get the half angle formula for cosine. Is that clear to you?
Yes.
So, Madhasabi, are we recording? Is it on recording? Can you check? Do you see recording somewhere?
Yeah.
It is recorded, right?
Yeah.
Okay, so let's continue. So you have learned. So Madhasabi, any doubts so far?
No.
Easy?
Yeah.
Okay. So this time I will do another half angle formula, but this time for sine, right? So let's go to another page, and this time we'll do half angle formula for sine. Okay. So if I have to get half angle formula for sine, from where should I start? Tell me, Mata Savia.
From 2 times sine
Correct.
to theta.
So tan 2 theta is equal to 1 minus 2 sine square theta, right?
Yeah.
So this formula, this time I will say, well, let 2 theta equals to x, then theta will be x by 2. Substituting the value, I get cos of x equals to 1 minus sine square x by 2. Now I'm rearranging. I'm writing sine square x by 2, taking it on the left side, and 1 minus cos x on the right hand side. And now square rooting, I get what? I get square root of 1 minus, oh, sorry, it was 2 here. I forgot to write 2 here. Okay. So 1 minus cos x over 2 square root with plus and minus sign. Do you see the half angle formula this time? So simple. So basically, again, when to use positive, when to use negative, really depend on which quadrant you are in. So based on that, you can now find the value, correct?
Yeah.
So can you tell me what is the value, exact value of sine 15 degrees? Sine 15 degrees will be in quadrant 1, so it will be positive, correct?
Yeah.
So tell me, how will you find sine 15 degrees?
Okay.
You know the sine 30 degrees?
Yeah, I know so.
Half, right? So we can say, well, sine of x is 30 divided by 2 is 15 degrees, correct? Equals to plus minus 1 minus cos 15 degrees over 2, right? Do you see that? So now
Yeah.
we have the value of sine of 15 degrees. And it has to be positive since we are in quadrant 1. And we know the cos of 30 degrees. This should be cos x is 30, sorry. I have to write 30 here, correct?
Mhm.
Because x is equals to 30, x by 2 equals to 15 degrees, correct?
Yeah.
And therefore, I will write here cos of 30 degrees. Let me write clearly. So cos of 30 degrees is square root 3 over 2. So we have 1 minus square root 3 over 2, correct? Divided by 2. Do you see that, how we have figured it out?
Yes.
Now you can take the 2 common and you get this is equal to. So 2 goes down. So we get half outside because it becomes 1 over 4. We get square root. We get 2 minus square root 3. Common denominator, right? So that becomes the exact value of sine 15 degrees. So these half angle formulas are very, very important. We can now find the exact values of many angles, right? For example, we know that the exact value for tan 45 degrees is 1. But what is tan 22.5 degrees? We can use the formula and get it, right?
Yeah.
Not only that, we can do even half of that. So we can keep on now finding many values, the exact values, using these particular formulae. Is that clear to you? Correct?
Yeah.
So we have learned all these techniques. Here are some test questions for you. Madhusavya, these are the 3 test questions for you. I will like you to prove these identities. First one, cos 2x is 2 cos square x minus 1 and 1 minus 2 sin square x has been already done, correct?
Yeah.
Second one, what is the value of cos 3x? Similarly, you can find the value of cos 4x, cos sin 3x, sin 4x, correct? You can use these formulas to find other values. Now, here are 2 questions which are left for you to do. So that is your homework, right? So try them out. Is that clear?
Yes.
So this can be extended, as you can see, to sine also. So now you can also find the value for sine 3x, sine 4x, correct?
Yeah.
So that also you can add to your list. You can continue with tan 3x also. Is it okay? So it is up to you to explore and learn more from what we have already learned. So combining these formulas, which we began with, you can actually get a whole set of trigonometric identities relating many angles, combination of these angles, correct?
Yeah.
So here we began with the compound angle formula sine A plus B equals to sine A cos B plus cos A sine B. Sine A minus B as sine A cos B minus cos A sine B. Cos A plus B as cos A cos B minus sine A sine B. Cos A minus B as cos A cos B plus sine A sine B. From there, we derive the double angle formula listed here. Sine 2x equals to 2 sine x cos 2x cos square x minus sine square x, and cos 2x formula could have been written in many different forms. In addition, we also found the half angle formulas, right? So for cos x by 2, we found that it is plus minus square root of 1 plus cos x over 2. And for sine x by 2, the formula was what? It is plus minus 1 minus cos x by 2, correct?
Yeah.
So we can actually derive double angle formula, half angle formula, and all these from these. And we also worked on tangent ratios and derived the related formula. So with that, we end our class today. Do you have any doubts, Madhasabi?
Oh,
So I'm stopping the screen now. I would like you to summarize today's learnings. It's all up to you, Madhasavi. Summarize, what did you learn today?
yeah. And today's class, I learned about we can derive the double angle formulas and half angle formulas
Correct.
from the idea.
Yes. So try some questions from your book. On my YouTube channel, I've got hundreds of videos related to this chapter. I'll share some playlists with you. Go through them, answer the questions, and you have 2 homework questions also to do. So try them also. Is it okay?
Yeah.
So now, looking forward for the next class. In fact, looking forward for the next beauty of your country. So share, get ready with that. Okay?
Yes.
Good. Thank you and all the best.
Thank you so much. Bye.